All right. Our next speaker is Andrea Polidari, and Andrea is the Quality Assurance Manager at the South Coast AQMD in the Science and Technology Advancement Decision, where he has overall responsibility for the QA functions for environmental measurement programs. Prior to joining South Coast AQMD, he was a research assistant professor at the University of Southern California, where he taught courses and conducted extensive research on particulate pollution and its health effects. He received his PhD in environmental sciences from Rutgers University and his bachelor's degree also in environmental sciences from Urbino University in Urbino, Italy. Andrea.
The clicker. Okay, so yes, I was born and raised in Italy, and I realized that I still cannot match Eric's superior hand skills and movements. So one only suggestion, Eric, something that you may want to add to your arsenal is this. Because it can be used for pretty much everything. What are you talking about? You can emphasize things, or where are you going, and so on. So I'll teach you later. So today we'll talk about, as the title says, unintended consequences of not following proper air monitoring station operational procedure. And I would like to acknowledge, the help of Mike Hamden and Brian Vlasic that also work. Mike works in my group, and Brian works in Jason's group. So first of all, I would like to basically emphasize the fact that any ambient air quality monitoring network is a very complicated system, which main objectives are provide air pollution data for the public, support compliance with the national ambient air quality standards, and support air pollution studies. A successful operation for an ambient AQM network requires several steps. Here I listed just some of the most important, which include careful planning, coordination of efforts between different people working in different divisions, of course, following established procedures, which is the main topic of this presentation today, continuous oversight, and of course, much more. An ambient AQM network is a very complicated and complex system, and as you can tell from the chart on the right, bad data can impact the entire AQM process. So these are some of the implications of not following the established requirements. First of all, you have data reliability and data defensibility. If you produce unreliable and undefensible data, then this bad data may impact the agency's air monitoring objective, of course, agency state and federal requirements, policy decision, health assessment, and data comparability both to other standardized measurements and also between operators and instruments. In terms of data defensibility, if you produce undefensible data, of course, other agencies and organizations may challenge the validity of your data, and for this reason, as it has been emphasized many times before during this, the previous presentation, you should always be able to demonstrate proper collection and validation of data and proper documentation. In terms of other implication of not following proper procedures, operational procedure, there is staff time. Of course, if you produce bad data, you're going to have to spend time dealing with corrective actions, dealing with additional time used to repair equipment, testing equipment, and recalibrating equipment. You are going to have to spend additional time dealing with data review and validation. And of course, your staff and your supervisor, your managers would have to get additional training to get up to speed with whatever they need to learn. Other consequences, there might be delays due to data submission and certification, delays that have to deal with satisfying other EPA requirements, delays related to reaching data quality goals and objectives, and of course, delays due to the fact that you're going to have to implement important decisions both from the regulatory, legal, and the health risk standpoints. Other consequences have to do with enforcement. So there's definitely going to be, you're going to have to spend time dealing with disciplinary procedures, more stringent audits, both internal and external audits, and of course, as I said before, dealing with corrective action. Okay, so in the most serious cases, if you don't follow proper operational procedures, you might get in a situation where your area is designated as a non-attainment area. So you have to deal with this kind of very serious consequences that potentially might include potential sanctions and loss of funding, time and effort that you're going to have to spend developing SIPs, state implementation plans. You're going to have to deal with tighter rules and regulation, additional permitting requirements, and loss of economical development, just to list a few. Of course, some other unwanted consequences of not following procedure also include unplanned expenses, so all costs related to lawsuits or litigation with environmental groups, community groups, regulators, and other private and public institutions. Two other important consequences that made the list are reputation, of course. You might enter a situation where you start developing a bad reputation with the public. You might have a difficult time basically gaining the reputation that you once had once your image has been tarnished. And of course, all of these loss of reputation might even have an effect on staff and staff productivity in the end. And last but not least, media attention. So once you basically are known to be an agency that produce bad and unreliable data, this might affect the relationship that you have with the media, the agency image and opinion, and might produce, listed crisis in communication between the media and your agency. So the next part of the presentation, I just wanted to basically just talk about like a few practical examples of what could happen from a practical point of view if you do not follow the proper operational procedures. And in this slide, I listed basically a table that summarizes the most important steps to go from the sample collection or data collection to the data ingest. Basically, you go from a situation where you use an instrument, for example, to collect, let's say, PM 2.5 data, then you go, all the way down to, importing this kind of data into, in our case, what we call a DMS, a data management system, for, and the next step would be basically data validation and quality assurance on the data that you have corrected. So this is just the first part of the table. The second part that I'll show later will deal with data validation and in the end, every step that leads to data certification. The two columns here in the center and on the right-hand side of the slide, basically the central column is, see, I'm going to with my hands. So the central column is about potential sources of errors, okay? So pretty much it's not everything, it's not a very comprehensive list, but for the most part, we tried to list what could go wrong, for example, in the sample and analysis step and, down the list, data ingest step and so on. And on the right-hand side, there is a column basically that lists some of the preventive and corrective action that, we as an agency can take to make sure that, every step of the process is of the highest quality, basically. And, the system that starts with sample and data collection and ends with data certification is very complex. And there are only a very few ways to get it right, in the end, right? On the other hand, there are many potential ways to get it wrong, right? And one thing about errors that I've learned since I became a manager in the quality assurance division is that errors propagate very quickly. So you're better off trying to catch your mistakes right after they happen. Otherwise, you might not be able to track them down. Okay, so as a first example of what might happen during the sample and the data collection step. So, while I was talking to, the person in my group that deals with, auditing the BAMs and audits, our samplers in the field, and also, dealing with the operators in the air monitoring divisions. Basically, several times I brought up this example. For example, if you operate a PM 2.5 FEM BAM, some of the problems that might occur include that the nozzle is not cleaned very frequently. Sometimes the proper leak check procedures are not followed. And in some cases, the filter tape run out and is not replaced. I mean, this could happen. I'm not saying that this happens all the time. On the contrary, I had to spend quite a bit of time to try to find specific example of what goes wrong because, I'm personally proud to say that, all of our staff are very, very knowledgeable and do a great job in the field and in the lab as well. But potential consequences of basically, if one of these three problems happens, for example, if the filter tape runs out and is not replaced in time, you will see that the BAM continues to report the last good reading until the new tape is installed. It's very, quote-unquote, easy to catch this kind of mistake, but you understand that if you have a network, in our case with like 40 monitoring stations, and I believe we are operating about 7 of these FEM BAMs, then you can understand that it might happen that you start collecting bad data for an extended period of time, and then of course when you catch the mistake, then you are going to have to invalidate the data. And of course, the note is that FEM data may be eligible for comparison to the National Ambient Air Quality Standard for PM 2.5, which in our case, is particularly important. So we are always like, on the, this year in 2013, for the first time in many years, as I'll show later, we were able to attain that 3-year design value for PM 2.5. So you understand that every little detail counts, and so we want to make sure that we take these and other factors into account. So second example has to do with SO2 trace level monitoring, and also from the South Coast AQMD. There might be a situation where basically the instrument's zero value is highly negative because of calibration and or zero air generation problems. So of course the consequences are that the reported ambient levels are too low or even negative, and so the data completion is compromised. And this is actually quite a serious problem for our agency, and we are trying to address this with even with Region 9, when we had discussion with them. And so if you can take a look at one of the latest AMP 600 report for SO2, you can see that under the percentage completion, which is right about here, the percentage completion is some of our sites, not all of them, but is fairly low. And it's not because we think, for the most part, is not because an instrumental problem. Yes, that's part of the issue, but the main issue is that basically there's no SO2 in the South Coast Basin, right? We can definitely do a better job at improving the percentage recovery of this data, but in the end, this is one situation where we can do better, but it's probably going to take some time and effort, just because, as I said, the average SO2 concentration in the basin is extremely low. So another example that has to do with data acquisition, with the data acquisition system, and this is again a very theoretical example. These kind of problems maybe have occurred several times, but we were always able to catch them and to correct them in the end. But just to give you an idea of what it might happen. So when you deal with wind data, for example, we had situation where only the first few minutes of every hour were used to calculate the 1 hour wind direction average. And also we had situation where the incorrect calculation were used to calculate that hourly wind direction average. And so this might lead to unreliable hourly average wind data and to an incorrect data interpretation and analysis of the data. Just, kind of a silly example on the right. If you have a situation where the predominant wind direction is coming from the north, so just to simplify it, you have 50% of your wind data is coming from 350 degrees. The other 50% is coming from 10 degrees. Then in unfortunate situation where you have, for example, an intern in your group that all you can think about is just an arithmetic average, is going to calculate, let's say, is going to plot a pollution rose showing basically in this example where the NOx is coming from, and is going to reach the opposite conclusion, right? So the correct way of doing this is through vector averages. So the correct solution to this theoretical problem is that the NOx is coming from the north. But, of course, the intern that doesn't know any better might tell you, nope, the NOx is actually coming from the south. So. Okay, so this is the second part of the table that I was telling you about. So once you have ingested your data into your data management system, which is, something that we have developed in collaboration with the Bay Area with CARB. So basically, what do? You start your data validation, and you go down the list with all of the different steps that basically you have to do in order to arrive to a point where you are so confident in the quality of your data that you can go ahead and certify them, okay? So as an example, as a practical example of level 1 QC validation, here we go. For example, during one of our special monitoring campaign, we have been running what I define here as non-routine monitors. I don't know, maybe some of you are familiar with, these condensation particle counters for measuring ultrafine particles. The particular model we used here is 3783. They're made by TSI, commercialized now by Teledyne. And anyway, just to make a long story short, we are currently running 4 of these CPCs and 4 of these new generation ethylometers at 4 of our monitoring station. And basically, my point here is that, when you are using this kind of continuous instruments, you have to deal with a situation where you basically generate a whole lot of data. In this case, just an approximate estimate is about 350,000 data points per instrument per month. Okay, so it's extremely important to basically, since the data for the most part are collected manually, and since in this case they are not high priority, we have so many other things to take care of, and that we are interested in, that sometimes, just because, a lack of time, for the most part, we have a hard time to basically QC the data as we go. And this is extremely important, especially when you're dealing with continuous data, okay? So the potential consequences are that, let's say that you're using these monitors for the first time. If you don't check the data right away, potential instrumental and sighting issues, they go undetected, right? What, for example, if you placed your CPC monitor on top of, I don't know, Mount Wilson, you go there a month later and you see that the particle number concentration is close to 0, then oops, possibly I should have placed that monitor right next to the 710 or to the 405 freeway, right? I might get higher concentration if that's, that was the objective of my particular study. It's just, again, another silly example, but just to give you an idea of what, the type of procedural thinking sometimes that you should follow. So potential consequences have to do with, as I said, potential instrumental and sighting issues that go undetected, loss of a large amount of data, and of course the data interpretation is compromised. If you go back and take a look at your data a month, 2 months later, and you see that you have a data completion of 50%, then trying to interpret this kind of data is very, very difficult. In terms of comments, when possible, of course, try to be proactive, okay? So your operators or your personnel in general should hopefully trying to perform the first level validation when possible. I think that's, in general is the best way to go. If you are the operator of this instrument, try to take ownership of your data and, don't just go down the list of the things you need to do and by the end of the day you've done them all. If you have 5 minutes, just open that file and see that, if everything is aligned according to, if everything looks the way it should, or if you get just an error mistake, or the data is compromised, or the file is unusable, then you should report that to your supervisor. Okay, so another example that has to do with level 1 and 2 data validation. And I think this is particularly important because, as you know, the PM2.5 concentration in the South Coast is PM2.5 has always been, along with ozone, one of our major problems. And as you can tell from the chart, take a look, for example, at the annual PM2.5 average and the 3-year designation value for PM2.5 also in 2012. They're very, very close to 15. But, guess what? We are out of compliance just because, they're over 15 micrograms per cubic meter. So this is just to stress and emphasize the importance of both data completion and exceptional event recognition, which is also part of following proper station operational procedures, right? So if, for example, let's say in 2012, if by any chance we didn't recognize then that some of our higher values, I don't know, let's say 50, 60 microgram per cubic meter data point, what if those data points that were very high and were considered to be valid, what if maybe, I don't know, the operator didn't write down a comment in his logbook that said, I don't know, there was somebody doing, I don't know, car wheels right next in the parking lot where the station is. Stuff like that. When you are at the limit and you are in a situation where just a few high data points could make the difference between attainment and non-attainment, that's very important. Okay, thank God this is not an example from the South Coast AQMDs, finally from another agency, but I didn't specify the name of the agency, but this was an instance where basically calibration data for ozone were uploaded into AQS. And, I believe in this particular scenario, this particular agency would have violated the 1-hour ozone standard if ARB didn't recognize the fact that along with their good data, this particular agency also uploaded calibration data. So as, it's not impossible. It can happen. Again, we have to deal with a system that is complicated, is complex. You have to deal with many different network stations. You have to deal with many different operators that use the instrument in somehow, different ways. And so this kind of things can happen. But again, there is a note here too. It's fair to clarify that the problem was resolved in the end. So I believe this is the last example, and has to do with this also happened at the South Coast AQMD, I believe back in 2010, when we were first starting using this DMS system, which is very powerful, but in the end we only had a couple of people that knew how to use it. And, basically there were a couple of data points that were extremely high, and here I'm talking about PM10 FEM, clearly outliers for not just because of the extremely high concentration, many other reasons. There were flags everywhere. So basically, when we used our DMS system, we were able to flag this data. They were appropriately flagged. But then, in the process of uploading this data file into AQS, for a reason or another, the flag didn't make it there. So for some time, I believe at the end of the year when, before the data certification, at the end of the year, before May 1st, before the data certification, where we did all our check of the maximum values, outliers, and so on, we noticed these 2 data points, and, it took us maybe a day or 2 to understand where they were coming from and to realize that finally there were erroneous data. So finally, I will leave you with, a couple of final thoughts. It's impossible, virtually impossible, to eliminate all issues, but steps can and should be taken to minimize these issues. And so, we have to deal with a very complex system, and especially, in the past 5 years or so, and, in the next 5 years, 10 years or more, because of the technology that is being developed and will be developed to make our life easier. when you deal with the new variables, there are new problems, and therefore there are new mistakes. So I believe, that the operating network monitoring station, operating instruments, and following proper operational procedure is just an endless process of assessment, reassessment, reassessment, and improvement. It's never ending. So this person over here, which I think you have heard of before, Albert Einstein, said that anyone who has never made a mistake has never tried anything new. So what I really think that he meant was that make new mistake, but learn from the old ones, right? And another very interesting individual, Dr. Edward Deming, which was one of the most prominent statistician of the 20th century, one of the father of QA in the automotive industry. He said that it is not enough to do your best. You must know what to do and then do your best. But also, I have my own personal interpretation of this, and I think that what he meant is it is not enough to do your best. You must learn proper air monitoring station operational procedures and then do your best. And thank you. Questions? All right. Thank you very much.